All right, welcome back to Mrs. Bailey's Math AP Pre-Cal. Yay! Yes, subscribe below. Subscribe below. All right, now we are going to go over some transformation functions. First, let's go over the rules of these transformation functions. Now, with transformation functions, we have a f of x, which we could also state that is our what? Our y. Now, when we have anything added to the entire function, y goes in what direction? Up and down. So if it's plus c, we're going up c units. If it's minus c, we go down c units. All right, so that is whatever the y is, whatever the function is, up, down. All right, any questions on that? All right, now when we're dealing with the x's, just like an x, they lie. Both face. Yeah? They both face lie. So, them x's be lying. That's why they call it x. Okay? Okay? So, inside with the x, if it says plus c, x moves in what direction? Left or right? So if it says plus c, it's a liar. It's not going to go towards the positive, but it's going to go towards the negative. X's be lying. All right? And I'm trying to tell you. Okay, bring it back. All right. Now, if it's inside with the x and we are subtracting, remember the x's lie, so we're not going towards the negative. We're going to go towards the positive because the x's is a bold-faced liar. Just a whole nother thing because hey, x's be lying. All of them. Now, when we have reflection, this reflection part is a negative y. When we have negative y, the best way that I can remember negative y is in order for me to have a negative y, it needs to reflect across the x-axis. What was positive y turns to negative once I reflect across the x-axis. That's when my y is negative. But when my x is negative, in order for my positive x to become negative x, it needs to reflect about the y-axis. All right, and then we have a vertical and horizontal stretch and shrink. I don't know if y'all know much about Bugs Bunny, but Bugs Bunny back in the day, they had where they stretch his face out wide and they cram it in. When we dealing with values, that a value in front of the y doesn't lie. So we're gonna, and the y goes in what direction? Up and down. So if it is in front of the y and that value is greater than 1, then that y value is stretched vertically. All right? Now, if it is between 0 and 1, like a fraction, then it is compressed vertically. All right? Now, if that a value is only in front of the x, remember the x values, the x's lie. They both face lie. So, besides being, if that a value is greater than 1, besides being a stretch, it's going to go opposite and compress. Because we know that our x value go left to right. All right? And if that a value is between 0 and 1, which is a fraction, besides compressing, that x will lie and expand left to right. Okay? Now, y'all ready? Let's go over it. I don't know what happened to my All right. So now let's go ahead and go over these transformation rules. This is in review A, topics 1.12 through 1.14. Now, we're going to break apart each part of this equation to see what is the transformation. First, inside with the x, we know that the x's does what? They lie. So we know x is moving what direction? Left or right? So if I'm going the opposite direction, am I going towards the left or the right? The right. So this is you moving g of x. Oh wait, no, I'm sorry. This is f of x transformation. So it moves, and when we talk about left and right, it is horizontal. So the function. Mm-hmm. Sure. Does anyone else see one? Transformation from yesterday?
What color is your brown? What color is your brown? In your brown, not the dark brown.
I can do your hair. I can do your hair. Anyone else? Sorry.
It's math time.
I'm sorry.
Oh.
As we were saying, the function f is horizontally translated 2 units to the right. Also, that 3, is that 3 in front of the x, or is it in front of the entire function? It is in front of the entire function. Does our y lie? No. So that is a vertical stretch by a factor of 3.
Can you also describe a vertical stretch by the graph getting like less wide? Because that's how I described it. It's like it becomes like less wide.
Well, when you vertically stretch something, it does pull in on the sides.
Yeah, so getting less wide.
But the only thing is that the only thing that changes, which I'm going to show y'all in the delta math, is the y value, not the x.
Yeah.
Even though it looks like the x is changing, it doesn't change. Vertical stretch. A factor. And there's a reason why we say factor, because the y values is multiplied by this 3. All right, so for number 2, let k be a function that is a transformation of the function h such that k of x equals h 4 of x minus 1. Now, that 4 inside with the x, we know that the x's does what? They lie. All right. And we know the x's, is it vertical or horizontal? Horizontal. So that's going to be horizontal dilated by a factor of, and how we change this is What is under all whole numbers? So if I flip it, it would be what? 1/4. So it's horizontally dilated by a factor of 1/4.
So, yeah, so it's like compressed.
Yes. Even though it would look like it's stretched, we know that the x's lie. By a factor of 1/4. That means all of our x values is going to be divided by 4. All right? And then that -1, is that on the inside with the x or on the outside? On the outside. So is that dealing with my x or my y? My y. And my y moves in what direction? Up and down. So if it's minus, it is going to move down 1 unit. All right. So what you're focusing on is what is in front, what is with the y, and what is with the x. That's how you can tell it apart. I'm sorry? Because the x's does what? Both ways. So if the
Since
x,
it's 4 times x, the opposite would be 4, or x divided by 4, which is 1/4.
yes. Good way to explain it. Bada bing, bada boom. All right. Any questions so far? Does everyone got this? Okay, I'm sorry. You got to dissect every part that was added to the function. I kind of think of this like coding. I feel like robots could be made like this. Moving up, down, left, right. Yeah. Mm?
Hey, there's a, hey, Miss Bailey.
Yes.
Hey, Miss Bailey.
Mm?
There's a BUGOBWALL.
Oh, a stinker bug?
Yeah, does somebody like, kill it? Can you kill it? Your boy.
Oh, yeah, sure.
What if it flies? Bro, they do not be sick. I've never smelled it.
Are you?
I've never.
No. I had just killed one of those stinker bugs.
I've never smelled one.
No, but my son used to be so afraid of them bugs. Thank you.
So then at that point, I'm already up. I'm on dead.
Now you're gonna sleep.
He ain't scared. All right. Everyone got this? Cool? All right, let's go to the next one. Breaking it down. First, that 5. We're going to go in order. That 5 is in front of is that in front of our x or in front of our y? Our y. And our y doesn't lie. So is our y vertical or horizontal? Vertical. So it's a vertical stretch by a factor of 5. That's an H right here. Now let's go to the next one. Oh, I'm sorry. What's it going on inside the parentheses?
X divided by 2.
Mm-hmm.
That
Yes.
by 2.
Yes. Because the x's lies. It looked like 1/2, but we're going to flip it because the x's lies. So that's a horizontal stretch by a factor of 2. And the last one, the 3, is that with my x or with my y? My y. So that is a translation, a vertical translated by how many units? 3 units, what direction? Excellent. Vertically translated 3 units up. Yes, ma'am?
Could you explain again the horizontal stretch by factor two? How we got that?
Sure, yes, ma'am. Because it says x divided by 2, that's just like saying 1/2 multiplied by x. And we know that our x's,
So X is just assumed to be 1, right?
oh, no. Well, if we don't see any number in front of it, we automatically know it's going to be 1. So I could pull it over to the side and see 1/2 in front of it. And we know that the x is lies, so then I could flip it and it'll just be 2.
Wait, the X.
Or it's like,
X is lies.
that's saying divide by 2.
What I mean?
Multiplying by 2.
What it looks like I would compress it, but it lies. I stretch it. If it looks like I go to the positive, it lies. I go to the negative. Opposite.
So if you multiplied it, it would be a compression.
Yes.
So why does it do that?
Because the x is lies. Well, that's how I remember it. It works for me. Just remember, every time it's around the x is a liar. I'm not projecting. Alrighty. Let n be a function that is transformation of function m such that n of x is negative 2m of negative x. Describe the transformation of the function m that resulted in the function n. All right, so for a function, this is number 4, that negative is in front of the x or in front of the entire function? All right, so we're dealing with our x or our y? Our y. In order for our y that was positive to become negative, it had to reflect across the x-axis.
Are we always dealing with Y?
Only if it's not with the x. If it's inside with the x, we're dealing with the x.
The number?
But that negative on the outside is a negative m of x, so we're dealing with a negative y. So just we dealing with that negative first. That, oh yeah, we got another reflection. I do it in order. So first it's reflected first because this is negative in front of my y. In order for my y to be negative, it had to reflect across the x-axis. All right? Positive y reflect across the x-axis to become negative y. So that negative is a reflected yes. All right. Now that 2, is that in front of the x or in front of the function? The function. So is that horizontal or vertical?
So if there's a negative in the front and in the parentheses, that's the reflection across the X, but you said we was looking at the Y.
Yeah, we're looking at the y, but in order for a positive y to become negative, it has to reflect across the x-axis.
If you wanted to like place this at Desmos and just check your answer, I know it'll be checked with everyone has to. But would the M just become another X or would it be a Y?
Yeah.
Because if it's an X, then the function, it's almost like the negatives cancel out and it doesn't reflect.
Well, that's a great question. Well, that M of x, F of x, G of x on the back of your transformation sheet, what those are parent functions that are transformed. It starts with the parent functions, and then all the transformation is added to the parent function. So right now we're not dealing with parent function, we're dealing with any type of function, and we're able to move it up, down, left, right, stretch, and compress. Yes, ma'am. Vertical stretch by a factor of 2. Look at all right. And that negative x, just like Aisha has stated, in order for my x's that was positive become negative, it has to reflect across the y-axis.
But that would just change nothing, right?
It depends on what type of function.
But in this function, it changes nothing, so it's pointless to write.
We don't know what the function is. We don't know what it would look like.
Okay, that makes
I love transformations. Don't y'all? So, you'll love it. Alrighty. Does everyone? Oh, okay. When y'all finish that, let me know. Now the next one is a lot easier. We just plugging in. I feel like math could be like a game. The fun game. All right, everyone got this? Everyone got it? All right, let's move it up. Ooh, look at this funness. I know I don't want to take all the fun from y'all, but look at this funness. So look, we're gonna use the table below. Gives values of the function f at selected values of x. Use the table to answer 5 and 6. They gave us g of x equals f of 3 of x plus 2. And we need to find what g of 3 is. So g of 3. What did that replace? The x. So that 3 replaced the x. So I need to replace all my x values with the number 3. All right? 3 times 3 is 9. So I have f of 9 plus 2. Now, inside the parentheses is usually a what value? What letter? X. So when my x is 9, my y is, so that will be equal -6 plus 2, which my answer will be -4. The 9 is when my x is 9, my y is -6. Yes, sir.
So the G of 3 is the one that you put inside of the 3x.
The G of 3 says I need to replace all my x values with 3.
Okay.
Then when I replace my x values with 3, I have 3 times 3, which is 9. Now, f of 9 means what is my y value when my x is 9? When my x is 9, my y value is -6. So I bring that -6 down, plus 2 equals -4.
And that's what equals the x at G of 3.
G of 3. All right, so let's do this again. For our G of -1, G of -1 says I'm going to replace all my x values with what? -1. So I have f of 3 times -1 plus 2. 3 times -1 is, so f of -3 plus 2. So when my x is -3, my y is -1. So that's -1 plus 2, which give me my answer as 1. Any questions? All right, now let's do the h of x. We have h of 3, so I'm replacing all my what with 3? X. So I have h of 3 equal -2 f of 3 plus 3. 3 plus 3 is 6, so I got -2 of f of 6. What is my f of 6? 5. Excellent. And then that will be 5 times the -2, which will give me -10.
Oh, so you just forget the F?
Yes, because the f of 6 is my 5.
Oh,
Mhm.
okay, I see now.
All right, let's do it again. We have h of 0. We're going to replace all our x values with 0. Zero plus 3, 3. F of 3. When my x is 3, my y is -2. And -2 times -2,
It's +4.
+4. Any questions?
So when you do it, you just so at the beginning you just substitute the x numbers, and then once you get to the second part, you have to look at the table
Yes.
and then find the on the other table and then put that in for the third part?
In the equation, and finish the equation. That's right. Everyone got this? Yeah. Yeah, in this box. All right, everyone got this? I'm gonna go ahead and delete it. It can come back. I'm deleting. It's gone. Okay, there. All right, look at this. Look at this. The function k is constructed by applying 3 transformations to the graph of h in this order. Graph of h. Did I pass it?
Whatever's in the graph.
Oh. This says F. Maybe I'm tripping.
Maybe they just put the wrong one.
Oh, okay. This doesn't, okay. My fault. It gave us the equation, transformation equation. All right, here's the transformation equation right here. We are applying 3 different transformations to the graph of H. A horizontal dilation by a factor of 1/2. A vertical dilation by a factor of 3. And a vertical translation by -5 units. And we need to know what our A, B, and C is. Now that A, is that in front of our X or in front of our function? That's in front of our function. So we're dealing with horizontal or vertical. Vertical, excellent, and it doesn't lie. So they said it was a vertical dilation by a factor of 3. So A equals 3. Let me do my verticals first.
Then B is 2.
Hi.
The opposite 1/2.
Hi. Exactly.
So how do you know what
C is -5.
your B is?
My B is inside with my X, and we know that the X's lies.
But how do you know in this sentence? Like what words tell you like, oh, this is
Horizontal.
Horizontal.
so if it's horizontal dilation, it's B.
If it's horizontal, left to right, dealing with my X, and my X's lie. So besides saying 1/2, I'm gonna flip it and say 2.
So would that mean it would get? Would that mean it would shrink?
That means it was stretched. That does the opposite. I mean, it will shrink. Yes, it shrink.
What's
Yeah.
the dilation? Stretch or shrink?
Dilation is like when you get your eyes dilated, big, small, big, small.
But in this scenario, would it be stretching or would it be?
Stretching or compressing. Dilation, when you dilate your eyes, it gets big, small, big, small. But it's by the factor, it's going to tell us if it's going to get smaller or bigger.
Oh yeah, because positive.
Yes, if we say a factor that is less than 1, like a fraction, and it's not the X, then we're getting smaller. If we say a factor greater than 1, that is the Y, it gets bigger. But the X goes opposite. Everything is opposite with the X's. So our vertical translation, that means vertical movement, sliding by -5 units, that is our C. Any questions?
So the vertical is the A, the horizontal is the B, and
Vertical.
the vertical translation is what we see.
Yes. Exactly.
So what's H?
H is the function, the original function that was translated. They'll probably have like what's on the back of your sheet, one of the parent functions, a quadratic. But in y'all cases, it's not really a parent function. Y'all just got any kind of function, like this one. It's not a parent function. Gosh. All right, let's construct it. We're gonna construct it. All right. Any questions on this? We're gonna start making them. All right, now look at this. The graph of y equals f of x, consisting of 3 line segments, is shown for -4 to 4. Sketch a graph of g on the same axis above, where g of x is f of x plus 1 minus 2. All right, first, inside with the x is plus 1. But we know that the axis does what? They lie. So, x is moving what direction? Left to right, or we could say horizontal. Let's use horizontal, okay? So we can make sure we can use horizontal. X's move horizontally. So, if it is plus 1, it's going to move horizontal translation to the left. All right? My x point to the left, right there, to the left one. But that's not all. What does that minus 2? Is that with the x or with the function? With the function. And the function, or the y, moves how? Vertically. So this is going to vertically translate down 2 units. This point 1, 2. This point 1, 2. This point 1, 2. And this point 1, 2. Yes, ma'am. And now I just need to connect. Yes, sir.
For dilation, like what point should remain constant?
The part that's not being dilated. Only change, if it's a vertical dilation, only change the y of the coordinates. If it's a horizontal dilation, only change the x. Does anyone have any questions on this one? Oh. All right, did everyone get that? All right. Ooh, and we got a stretch and compress. I got a really good Delta math on this.
I think, so when it was that, next,
No, it doesn't. I might have to do it on the free version for a while. But gotta keep it going. All right. The free version doesn't automatically connect to your Canvas. All right. We're going to sketch the graph of H. Let's look at H. All right. So that 2 means what? Vertical stretch by a factor of 2. So all my y values will be vertically stretched by a factor of 2. Now, this negative x, in order for what was positive x to become negative x, it has to reflect across the y-axis. The y-axis. All right.
Can you stretch it, reflective?
Whenever you reflect, all you're doing is changing your x that was negative to a positive. So first, I'm going to try to get points. Let me get my coordinates. I got a coordinate at negative 3, 3. My x is now negative, so it's not negative 3, but that's going to be 3. My y, which is vertically stretched, is going to be multiplied by 2. So my next point is 3, 6. If I get another point, negative 1, 3. 1 because my x has turned to its opposite, and 6 because my 3 is multiplied by a factor of 2. If I choose another point, 1, negative 2.
Negative 1 and negative 4.
My x will be negative 1, and my y will be negative 4.
And then 4, 1.
And if we got 4, 1,
Negative 4 and
negative 4, and negative 2. Does anyone have any questions about these points? All right, let's plot them. So we have 3, 6.
I have a question.
Yes, ma'am?
So, I thought we were multiplying the y's by positive 2.
Mm-hmm. Yes, ma'am.
So then how do we get 4, negative 4, and then negative 2 in the last one?
Our y's at the time was already negative, so negative times a positive is still a negative.
Like the last one. I thought if you do
Oh, gosh. You're right. That is positive too. Oopsie doopsie. Thank you for that, Afia. So we got 1, we have 3, 6, 1, 6. We have negative 1, negative 4. And we have negative 4, 2. Best I could. All right. So as you can see, it reflected across the y-axis and it was stretched vertically. Any questions on that? No? Let's keep it moving. Keep it grooving. Oh, some more graphing, yay. All right, everyone got this? Mm-hmm. All right. Oh, Lord, look at all these transformations. Isn't it beautiful? Isn't it?
But this is pretty easy.
Oh, it is. Well, first, let's go in order. We have this negative in front of the function or the x?
That's
The function. All right.
Across the x-axis.
Reflect across the x-axis. Excellent. I'll just write down some notes. All right. That 2, is that
is this for this graph?
uh
Or was-
this one graph F?
Oh, okay.
That 2, is that in front of the function or the x?
Function.
The function.
Stretch vertically by 2.
Vertical stretch by 2. The 3 that's on the inside with the
Translate horizontally.
Is that horizontal translation?
left 3. Horizontal translated left 3. Horizon.
Another question.
Yes.
Is there any abbreviation for horizontal that should be used instead of writing the whole thing?
No, you don't even have to write the whole thing. I'm just trying to write it so that I can figure out where I want to sketch it.
Okay. It's pretty.
Because if I write the movements, then I can actually know my new points. Left 3. All right, and that +1,
Go up 1 vertically.
how can we say it?
Up, translate vertically up by.
Thank you. Perfected. All right. So let's get our points. First, the easiest way I could do is I want to know what's going to affect my x and what's going to affect my y. My reflect across the x-axis is going to reflect my, the y, okay. All right. Vertically stretched by a factor 2 is going to affect my y. All right. Horizontal translated left reflect my x, and then my y again. All right. We see that the y has the most change. Let's get our quadrants. Not quadrants. Coordinates. -3, 3.
-6.
So you're saying that the x value, which one affects the x? So it was horizontally translated left 3. So if it went to the left 3, -6. Okay. I need a minute to process. All right. Reflected across the x-axis changes my y. So what was +3 turns to a -3. All right. Then it was stretched by a factor of 2. So what was -3 is now -6. Excellent. And then it was vertically translated up 1 unit, -5. Y'all see how I did that? Then I got another point. I have -1, 3. My x, the only thing that affected my x was a horizontal translated left 3. So -1 went to the left 3, and now I have -4. All right. My y, it reflected, so my y turns to a negative, so that's -3. It was stretched by a factor of 2, so -3 times 2, which is -6. Excellent. And then it was vertically translated up 1 unit, -5. Now we have a point 1, -2. My x, all my x did was horizontally translated to the left 3. So I'm at what? -2. 1, 0, -1, -2. My y was reflected, so what was negative now becomes positive. Excellent. It was vertically stretched by a factor of 2, so 2 times 2 is 4. And then it was vertically translated up 1 unit, so 5.
So we don't use the equation, or if we use the equation to get what's being done for the graph, and then we use what's being done for the graph to solve the number.
Yes, to change the points.
And it's important what order we do it in, right?
I'm sorry?
It's important like what order we do the steps in, like for the y.
It would be if once we on Delta Math, it's easier if you do a certain order first. But since we're doing it based off the coordinates, all we need to do is change the coordinates based off the transformation. And our last point is 4, 1. Oh, you already got the answer. I was like, 1 negative. All right. So, horizontally translated to the left 3 gives me what for my x? 1. Reflected across the x-axis, changed my y to a negative. Vertically stretched by 2, change my -1 to a -2. And vertically translated up 1 unit, change my -2 to a -1. So we have our points, -6, -5, -4, -5, -2, +5, and 1, -1. Yes, I can. All right, y'all see? Any questions on this? This will definitely help with our next part. Because we need to know what affects the domain, which is our what? And our range, which is our. Okay. All right. Everyone got this? Yes? All right. The domain, which is our x value of the function, is from -5 to 10. The range, which is my y value of h, is from -4 to 2. Find the domain and range where g of x is, we have x minus 5. X minus 5 does what to the function? Horizontally translated right 5. Vertical translated what direction? Up 7. Excellent.
So would the domain be 0 less than or equal to x, as then less than equal to 15?
Excellent. Since it was horizontally translated, right 5, all our domains will move to the right 5. So that -5 will go to 0, and that 10 will go to 15. Now the range, since it was vertically translated up, seven, our range, which is our y, will go from 3 to 9. Excellent. Any questions? How we know? Yes, -5. Since it's going to the right 5, that means going towards the positive. So if I'm at -5 and I go right 5, I'm at 0. If I'm at 10, I'm going right 5, I'm at 15. Now, vertical translated up 7. If I'm at -4 down here, if I go up 7, I'm at +3. If I'm at 2 and I go up 7, I'm at 9. Any questions? All right. Let's do it again. All right. The domain of the function is -4, 8. Range is -7, 3. Find the domain and range. And let's see which one affects which. Now that 2, is that going to affect my domain or my range? My range. So that is a horizontal or vertical? Vertical stretched by 2. By a factor of 2. All right? That 3 under the x, I could move that out. I could move the x out and make it a what? 1/3. We know that the x is lie, so it's 3. And when we're dealing with our x, we're dealing with a horizontal. All right, horizontal. Stretch by a factor of what? 3. That's dealing with my x. All right, and the last one, the plus 1, is dealing with my y, which would be a vertical translated up by what? By 1.
One question.
Yes?
So the x divided by 3, it would be a horizontal stretch or a horizontal translation? Or can it only be horizontal stretch?
Because it would look like it is a horizontal compression, but x does the opposite, so that's be a horizontal stretch. Mhm. So we have what will affect our y's and what will affect our x's. So let's first do our domain. The domain was stretched by a factor of 3. So my domain, you multiply your x values by 3. Negative 12 to 24. Any questions?
I have a question.
Yes, ma'am?
So where did the negative 12 and 24 come from?
Since our domain is currently negative 4 and 8, our horizontal stretch is the only thing that affects our domain, which is our x values. So we're going to end up multiplying that x values by 3. 3 times negative 4, negative 12. 3 times 8 is 24. Now we're going to do our range. Our range is our y value.
Negative 13 to 7.
All right. So you did negative 7 if it was vertically stretched by a factor of 2. That gets us to negative 14. Then it was vertically translated up 1, so that is negative 13.
How do you know which one to do first? Just by the order in the function? Because I think I did like up by 1 first to get negative 6, then times 2 to get negative 12.
I do the stretching compress. I do the stretching first.
So,
Like order operations, right?
Mm-hmm. So first is vertically stretched. We're going to multiply it. Negative 14. It goes up 1 unit. That's negative 13. And then our 3 vertically stretched by a factor of 2. That's, and then translated up 1. That's 7 up 1. Any questions? Yes? Yes. I know this is a lot, y'all, but we almost done with Unit 1. But this is the last part of Unit 1, the transformations. But now y'all gotta get ready for a test.
As long as this is the bulk of it.
Well, it's the polynomial rationals and transformation. Okay, we keep it going. Everyone got this? Told you I want to make sure y'all ready. All right, the domain of the function of f, which is our what values? Our x values, is from negative 10 to 0. Range, which is our y, is from negative 8 to 6. That negative is in front of the function. In order for my y to be negative, it has to reflect across the x-axis. And I'm just gonna put a note that affects my y. That 3,
Vertical switch by factor.
excellent. That 3 is in front of my entire function, so that is a vertical stretch by a factor of 3.
Horizontal shrink by factor of 1.
And then that last one is that horizontal.
By factor of 1.
Can we use that other word? Horizontal. Start, D? Start with it, Dilation. Horizontally dilated. By a factor. Flip it.
1/2.
That affects my x. So all my x values is going to be now divided by 2. And we see what's going on with my y. First, what is my domain? So if my domain is -10, 0, and now it's being dilated by a factor of half, it would be -10 divided by 2, which is -5, and still 0. Now my y, which is my range,
Do we flex first or stretch?
stretch. Really doesn't matter because it's going to be just turned to the opposite on that one. So that y, that -8 turns into a positive 8 because it was reflected. And then we're going to multiply it by a factor of 3. 24, all right? That that 6 would turn negative, which is -6. Multiply it by 3, -18. Any questions?
Would you flip
Ah,
negative
dang.
18 to 24?
Yeah, dang, come, I messed up on that one. Yes, the small one first. -18 first. Thank you, Charles.
Wait, that matters.
Huh?
That matters.
Yes, because you always go from least to greatest. Oh, and now we got the one where we put it in the calculator. Yay! Yeah, I love y'all too. All right. Everyone got this? All right. Now the table above provides data for 7 ordered pairs. Which function type best models the data in the table? Linear, quadratic, or cubic? Explain your answer using characteristics from the data in the table. All right, we're going to go to Desmos Graphing Calculator.
It's only those 3 options.
Okay. If you want to, yes, it is. If you want to do it based off the table.
I think it's technically pentag.
Is what?
The fish difference is constant.
Ooh. Okay. But we're not doing. Because that's a lot. Yeah, we're trying.
Maybe write for regression model.
Yes, it's a regression. It's a regression.
What's a regression?
Regression is when we actually have to plug it into Desmos tables. So we go here, go to table, we get our X and our Y's. So we got our X's at 0, 2.5, 4 point, dang, keep messing up. 4.1, 5, 6.1, 7.5, and 10. Put in our Y values, 40, 11.5, 3.4, 2.1, 3.7, $11.25, and 39.5.
Yeah, tape I could use to hang up a poster like that.
Yeah, I got one there. All right, we're going to zoom out. Now tell me, which parent function does it look like? A quadratic. So now we need to be able to get the equation. Quadratics is in the shape of a parabola. So we need to be able to get the equation by
You just kind of click on a thing on the side, and then it gives you a,
is it this one? Oh yeah.
yeah, that, and then set it to the,
Since it looked like a quadratic, it's a quadratic regression. And we got our equation. They give it to us.
Is it that big?
Is that on the test?
Yes.
No, like,
But-
can you do all that on the test?
Yes, it's calculator active on this one.
They give you that exact
Equation?
stuff, no, they give you that exact,
that's
tools
no, yeah.
to do.
Well, I got the decimals. Let me try it on the decimals testing calculator.
It works on the test that you guys are,
Okay.
yeah.
Zoom in. All right, so here's the equation, y'all. First, we know that it's quadratic. That's why we did a quadratic regression. It looked like a parabola. And then they gave us the equation.
What do you write for the residual one?
And the residual,
Where it's 6.1.
was it this one? When our X is, no, when our
3.7.
X is, I forgot how to do this. Dang. How to do this again? Let's see.
This one. Aquela scissor. Aquela scissor artística depois.
Yeah. Dang, I forgot how to do this
Do we
part.
leave it in a minute?
Hmm?
Do we leave it in a minute? Or do we leave out one?
Dang, we leave in a minute. But I gotta figure out how to do this part again. I forgot. Residuals.
We leave it at 60.
Alright. Right, when my Y is 6.1. Oh, 3 point, okay. So when my X is 6.1, my Y is 3.7. So that's 3.7 minus the actual. I'm gonna actually plug in using this equation. I'm gonna replace my X values with 6.1.
Are you going to the state there?
All right.
I just.
So the residual point would be the 3.7 minus this value, which is negative 0.08514. The residual is the difference between what was actual and what was predicted.
Oh, I did that.
Any questions on that? Do you have any questions? All righty then. I'm going to cut out the recording.